Okay, we've got a question on long division of rational expressions. So we'll just start with the long division algorithm, which we know how to do. So I've asked everybody to do this, and everybody appears to have gotten it right. Let's see if I can get it wrong. Okay. So, and if you're watching this and haven't done it, it'd be prudent to do this. Okay, 7 into 3298. Okay. 7 will go into 32 4 times. Meaning if you put a 4 here, you're gonna have 4 times 7 is 28. Okay, and that effectively gets you 2,800 out of this. Okay, you want to make up a 3298, put a 4 in this position, that's going to be 400 and something. Well, 400 times 7 is 2,800. And we did even write 2,800 down here if we wanted to. So we've got 2,800 out of the 3298. Okay, and it's a good way to understand it. I don't know if it's ever been explained that way. It's usually explained as you do this, then you do this, then you do this, and there's no real understanding of what it means. So if you can grasp the understanding of what it means, it'll help you understand the process of long division of rational expressions, a long division of polynomials. Okay. Okay, so anyhow, so by putting a 4 here, we made up 2,800 of this. And we still got 42 or 498 to go. Okay, well, we subtract here. And then we bring down the 9 because that's all we really need to figure out how many of these we need to make 498 that were left. We could have written down the 498. It wouldn't have hurt anything, except then things wouldn't have lined up quite the way they do if you're taught to do it by rote. So since most people are going to learn to do it by rote, I'm not going to do that. Okay, but it could have been done. Well, 7 into 49 is 7. So at this stage, this really stands for 490 because that 7's in the tens place, right? That really stands for 70. 70 times 7 is 490, and we still needed 498. So we got 490 of them. We've only got 8 more to go. Okay, so, well, we divide this, or we subtract this, it gives us 0. And then we just bring down the 8. That 8 just stands for what we don't have. If we do 407s, which is 2,800, and 777s, which is 490, 2,800 and 490 add up to 3,290. And it leaves us just 8 anyhow. And then 7 goes into 8 one time. So we have the 7 here, and we got a remainder of 1, meaning that 471 gives us all this but 1. Okay. We can multiply 471 by 7, we get 3297, not 3298. So now the remainder is 1, and we can write that as, I'm going to write it as plus 1/8. Okay, that one, 1/8 plus 7. Okay. Now, I don't know if that explanation made a lot of sense, but I'm going to explain the long division of a simple polynomial. Let's take x plus 3. Into x squared plus 5x plus 7. Okay. Whatever I get here has to start with an x, because what I get here multiplied by this has to give me this. Okay. So what would I multiply by this to get this? I know I have to multiply by an x. So here we could even say, okay, we got x Okay, we do x plus 3 times x, we get x squared plus 3x. Okay, well, that means if we subtract x squared plus 3x from this, it tells us what we still have to get. Just like if we subtract the 28, which is really 2,800 from this, we get the 49, which is really 490. So by putting a 4 in this place, we get everything but 490 of the 3298. Okay, over here, we've got everything but, well, whatever we get when we subtract this from this. Okay, well, one thing you kind of want to do, get open math, I think tells you to do it. You want to put a minus sign in front of each of these, because when you subtract x squared plus 3x, you're really subtracting x squared and subtracting 3x. And we, of course, line the x squared and the 3x up with the x squared and the 5x here, because we're going to be subtracting like terms. Okay, x squared is a like term with x squared, 3x is a like term with 5x. And well, when we subtract, we get 2x. Okay, so we're going to need another 2x. Well, of course, then, well, I'm just going to do the 2x. Okay, so we're going to do the plus 2. I multiply 2 by x, I get the 2x. So when I subtract that, I'm going to subtract 2x plus 6. Now, I bring down that 7, because 2x plus 7 is what I still need when I subtract this 3x squared, or this x squared plus 3x. Okay, I subtract this and I end up with a remainder of 1. Now over here, I kind of keep track of what I'm doing. If I do x plus 3 times x, I get this, okay? If I do plus another 2x, well, you know, a pretty standard example, if I just multiply this with this, I'm going to get x squared plus 5x plus 6, right? Okay. Now, what I do with that remainder of 1? Well, I say this is plus 1 over x plus 3. It's analogous to the way I do plus 1 over 7 here. By doing this, of course, you know, what does it mean? For this to divide into this many times means if I multiply 7 by 471 and 1/7, I better get 3298. Okay. This divides this many times because this times this equals this. We're just trying to find what to put here, so this times this will equal this. And what we found here is an expression that multiplied by this will give us this. Now let's go ahead and multiply this up. Go ahead and use a distributive law and multiply this by this. A quick comment, I put a 2x here instead of just 2. Okay, it's just 2. Also, I didn't put my negatives, they're not. Oops. Now, we don't actually turn these to negatives. We, you know, this is still positive, just like we didn't turn that 28 to a negative, we just knew to subtract. We know we have to subtract this. So we put this little tiny minus signs here, or minus, got to subtract this from this, which is not going to be a problem because they're going to match up. But we gotta subtract this from this. We'll do some more examples. Get used to that idea. Okay, well. I'm gonna multiply this by this. Now, this isn't written out all that nicely, so I wrote it out a little more clearly. And how do we multiply this? Well, we use a distributive multiplier. X plus 3 times x plus an x plus 3 times 2 plus an x plus 3 times 1 over x plus. That gives us okay. X plus 3 times this plus x plus 3 times this plus x plus 3 times this. Now, the x plus 3 times 1 over x plus 3, of course, if it's going to work, cross it out, cancel it. Let's make sure that works. Okay. Just write these as two fractional expressions and two rational expressions in this case. And then when we get to the next step, we'll see that, well, if we multiply out the numerators, we get x plus 3. If we multiply out the denominators, we get x plus 3. And x plus 3 times x plus 3 is 1. All right, well, let's do this. We get x squared plus 3x here. And x plus 3 times 2 is x times 2, which is 2x. Plus 3 times 2, which is 6. And then we can do this. We can say, okay, we got x plus 3 over x. That's 3. And that's x squared plus 5x plus 6 plus 1 with the fifth x squared plus 5x plus 7. One other thing I did over here, to put down that little minus sign here. Okay. Okay, well, let's do one that's a little longer, and I don't know how this is going to come out. Might come out even, probably not. Okay, let's say we do come back. Okay. You almost died on me there. Okay. So we did a nice job of this. Everybody did a nice job. A few questions came up, so let's first go through this process. Okay. X plus 4. Well, we want to find a multiple of x plus 4 that gives us this. So it's pretty clear we're going to have an x squared. If we write out something times x plus 4 equals x cubed minus 3x squared plus 5x minus 2. It's clear that the first thing that's going to have to go here is an x squared. Otherwise, we're not going to get an x cubed. So we put an x squared. Okay, so, and then once we have an x squared here, it's going to multiply both the x and the 4. So we're going to put down an x cubed plus 4x squared. Now, what we're wanting to do is see what we've got left. Okay, because now having an x squared here gives us a good chunk of this. It gives us this much of it. Okay, well, whether you understand that or not, the rule is now we find something, we find what we get if we divide this into this. We find what we multiply by this to get this. It's saying the same thing. What you get when you divide this into this is what you got to multiply by this to get this. Okay. Okay, well, we got to subtract this because we want to see what's left. So we put a little small minus sign up here. We're gonna put a big minus sign out for parentheses around this, for example, because we're not really, we, we, we just want to write what we get when we multiply this by this and not lose track of it. So we can always check our results. But we put a little tiny sign here and here to indicate what we're really going to do with this term and this term. Okay, so we subtract x cubed from x cubed, of course, we get 0, and negative 3x squared and negative 4x squared gives us negative 7x squared. Now, we could bring the whole 7x squared plus 5x minus 2 down. All we need for this step is a 7x squared and a 5x. But it doesn't hurt us to bring down minus 2, and some people do that. So I'll go ahead and do it. It's optional, whether this one comes down or not. The reason being, well, we'll see. And so now we want to find what we multiply by x plus 4 to get this. Well, the one thing we know is whatever goes here is going to multiply the x plus 4. It's got to give us a negative 7x squared. So what do we multiply by x to get negative 7x squared? Or if of course, what do we get if we divide x into negative 7x squared? Either way, the answer is negative 7x. X goes into 7x squared 7x times, and we've got the negative sign. Okay. Or we want to multiply something by x, you get negative 7x squared, it's got to be negative 7x. Either way, we want to understand that. Okay, well, then we multiply the 7x by the whole x plus 4, and we get the negative 7x, negative 7x squared minus 28x. If we put the 28x under the 5x, okay, because it's a like term. We wouldn't put the negative 28x under the 2 because 2, negative 2 and plus a 28x, we can't add them. They're not like terms. We have simplify that. We have like terms here, so this works out. So we put a little plus sign here and a little plus sign here to remind us if we're going to subtract this from what we have here, which is what we still need to fill out the whole expression. If we're going to subtract this, then to subtract the negative 7x, we've got to add 7x. To subtract the negative 28x, we've got to add 28x. Okay, well, that gives us 33x, and we still need 2. We still need the negative 2. So there it is. And now we want to find out what we've got to put here, multiply with this to get us to 33. Or alternatively, divide this into 33x. Either way, you see, you're going to need 33. Because 33 times x gives us 33x. And now we've got all our x's. Okay, you see we've got this times this. If I just multiply this by what I've got here, I'm going to get x cubed, I'm going to get negative 3x squared, and I'm going to get a 5x. But I'm not going to get a negative 2. Well, how do I take care of that? Well, I complete the algorithm. I multiply 33 by 4, and that gives me 132. Now this is starting to disagree with, I think, at least one of the solutions I've seen, so we're going to have to check it and make sure it works. And if you got a different solution, probably going to want to check that. Anyhow, if I subtract this from this, I get a negative 134. So that is going to go up here because I've got to divide that by x plus 4 to finish this. In order to get that negative 2, I'm going to need a negative 134 over x plus 4. Now, the mechanics. The situation, just review, without talking about what's really going on and how we're building stuff up and subtracting stuff away, is. We divide the x into the x cubed. By finding what we multiply by x to get x cubed, well, it's going to be an x squared. So. We're gonna have to multiply that x squared by the x plus 4. You get this. We make little marks here to minus what we have to do in order to subtract. We put a little minus sign here, a little minus sign here. And we get a negative 7x squared. Now we still need a 5x and a minus 2, so we can write all those down. The minus 2 is optional. It's not going to line up with anything we get when we multiply this by this. But it doesn't hurt to have it. So if you like doing that, go ahead. Okay, so anyway, we find that x goes into negative 7x squared, negative 7x times, because negative 7x times x is negative 7x squared. We multiply the negative 7x by the 4. Then we get negative 28x. Now we've got to subtract this. For reasons that I've talked about, but the rule is we subtract. There's a good reason for it. Okay, whether you understand the reason or not, you got to subtract. And by subtracting the negatives, I'm going to have to actually add a 7x. To subtract a negative 7x, I got to add 7x. To subtract a negative 28x, I got to add 28x. I don't change these minus signs to pluses. I just write a little reminder sign up here to show me what I've really got to do. Because it's really, really easy, especially when you get into negative signs, to screw that up. I might already done it. Since my answer disagrees with the answer, somebody I pretty much trust on it. Okay, we'll see. We'll see. Usually, if I disagree, it's on. Okay. So we, in any case, add these. Well, we do negative 7x squared plus 7x squared. And I never did write my square on this thing. Okay, and that gives me 0. And then 5x and 28x gives me 33x. We still need that minus 2. So I'm going to write that down. Even if I didn't write it down here, it's not there, it's up here. I need it. Okay. I haven't done anything about getting that minus 2. Okay. So now divide x into 33x, I get 33. 33 times x gives me 33x. 33 times 4 is 132, unless I did my arithmetic wrong. Who knows? Got a minus here, minus here. Just a reminder minus sign, and I get negative 134, and I write that as negative 134 over x plus 4. Okay. Now, what I've done, I'm saying that this is x squared minus 7x plus 33. Even though I tried, I didn't leave myself enough room. So minus 134 over x plus 4. Well, let's write it out right. X squared minus 7x plus 33 minus 134 over x plus 4 times x plus 4. Okay, I'm going to shortcut this a little bit. Okay, I'm not going to write out the details of the distributive log. It's x squared times x plus 4, right? And that gives me x cubed plus 4x squared. That's from the x squared. And that minus 7x times x plus 4 gives me minus 7x squared plus minus 28. And of course, you see, right here's my x cubed plus 4x squared, right? When I do the distributive law, x squared times x plus 4. I can see it right there in my log division. And I see my minus 7x squared minus 28 right there in my log division. You might want to think about what that tells me. And then we have 33x plus 132 And then we have minus 134 over x plus 4 times x plus 4. You know, write that as x plus 4 over 1. And you see that I could as well write it as 134 times x plus 4 divided by 1 times x plus 4. So the x plus 4 can be put over the x plus 4, and x plus 4 over x plus 4 is just 1. So putting all this together, we have an x cubed. We have 4x squared and 7x, negative 7x squared, which gives us negative 3x squared. We got I'm gonna put my x on the 28. That should be negative 28x here, obviously. 7x times 4 is 28x. We got the then we got 28x and negative 28x and 33x. That gives us plus 5x. And notice that at this point, I've got negative x squared minus negative, I've got x cubed minus 3x squared plus 5x already. Right there it is. And the only thing I'm lacking is what I get when I multiply this out. Okay. Then of course that's my 132. And this, well, that's a plus 132 minus 134. Well, that's minus 2, isn't it? Okay, so that's finally x squared, x cubed. Okay. That's too much. So I'll write it down here. I don't know. We'll give it done in the first place. And there we go. Okay. Now we'll do one more. I'll just write it here. You can work on it, and then I'll clear up some more space. Let's try. A little tricky. But x squared plus 2. And x to the 4th plus 3x squared minus 5. There's several pitfalls in this. And actually, I'm going to put another one in, but put a minus on this 2, just to make us aware of how important it is to keep track of the negative signs. This thing is messing up terribly. So don't say anything. It's hard enough. Okay. So x squared minus 2 in the, well, we should look at. Okay. What do we need to multiply x squared by to get x to the 4th? We need x squared. To get x to the 4th, of course, we've got to multiply that by the minus 2. Okay, well, I'll use colors to keep things straight. But we're going to add the 2x squared and 3x squared. Or we're subtracting a negative 2x squared and 3x squared, which is the same as adding 2x squared and 3x squared. Then we have minus 5x. And we can bring down the plus 1 or not. I'm going to choose not to, just for the heck of it. X squared and the 5x squared and divided, I put minus that. No explanation. Okay. We're gonna need a 5 up there. It's 5 times x squared gives us the 5x squared that we still don't have. And now we've got it. And 5 times -2 is -10. And well, put a couple of signs in front of these. Let's remind ourselves. And we're going to get -5x plus 10. Because we can't add 5x and -10. So we brought down the 5x. Well, this is okay. Leads us to another potential area of confusion though, because we still need that +1, right? Okay. And that's or well, that's -5x plus 11. That's our remainder. So we can write this, didn't leave myself a lot of room. Okay. X squared is a higher degree than x. There's nothing but some kind of a fraction. And of course, it's going to be the fraction. So we can multiply by x squared to get a -5x. Okay. So we're done. We just put this over the x squared -2, then we check. Is that a great solution? Okay, I think we're right then. We'll consider that to be a check. 2 brilliant minds got the same thing. It's got to be right. Okay. Okay. Another way to have written this out. And it's kind of not a bad idea. A little more room. If I write this out, it's x to the 4th plus 0 x cubed. Then I got every power of x represented here. Just because I don't have any x cubes doesn't mean I don't necessarily want to write down. Okay. But then what I want to do is I want to do the same thing with the x squared -2. So I'm going to write that as x squared plus 0x -2. Then I'm not missing any gaps. I don't have any gaps. Okay. I've got all my teeth, no gaps. Okay. Got all my powers, no gaps. That makes sense. And it's kind of handy to do that. Then I can put my x squared up here. I'll get my x to the 4 plus 0x cubed. And then minus 2x squared. Then I make myself little notes whether I need them or not. What I need to actually do. And of course, the x to the 4th and the x cubed. X cubed. We didn't have any, we still don't have any, right? So I can't add it. So we get then 5x squared minus 5x plus 1. Okay, so it really didn't help all that much to have it here. But what's going to help is having it here. Then we should get less confusion about what to do here. Although, kind of did a pretty good job of understanding what that was. Okay, we got x squared plus 5. And that's going to give us 5x squared plus 0x minus 2 minus 10. Okay, then we know that that's going to be minus, that's going to be minus, that's going to be plus. Then we see that everything goes away, except well, we've got the -5, and that's lots of the left. We don't have to do any arithmetic by adding a 10 to the 1, which could create confusion. So it's always good to fill in any missing powers of X. Here or here. Makes it work out a lot easier. It just avoids a step of confusion. And it shouldn't create much confusion. You certainly know what you do with 0x cubed, okay? Okay, well. I want to do another thing now. I don't know if it's recording or not. It says it's not responding. It still says